question starts by giving us an equation for a collision, and we're asked to show that this collision obeys three conservation laws in addition to energy and momentum. So when we think about conservation laws, we should be thinking about charge, baryon number, lepton number. The only other thing we know about that sometimes gets involved is strangeness, but as the name suggests, strangeness is a bit odd, so it's better to avoid that one if you possibly can. So let's have a try at charge. Is charge conserved? So for charge, left hand side of the equation, well, it does say it's a neutral kaon. So neutral, 0 there, it's got 0 charge. For protons, we've got charge of +1. On the other side of the equation, a neutron, 0 charge, and a positive pion. Positive pion's got a charge of +1. So we've got a total charge of +1 on the left, +1 on the right. Is it conserved? Yes, so put a tick and we'll write conserved. Make sure the examiner's under no doubt what we've done. Right, so we'll go at baryon number then. Is the kaon a baryon? Well, if we can't remember anything about kaon, let's have a look at the data sheet, see if there's any clues on the data sheet. K particle, well, it's in here, it's called a K meson. It's its proper name for a kaon, K meson. So are mesons baryons? No. So the kaon isn't a baryon, so its baryon number must be 0. Is the proton a baryon? Yes, it is, so its baryon number is 1. Is the neutron a baryon? Yes, it is, so its baryon number is 1. Is the pion a baryon? Well, you might remember much about pions, but again we can have a look at the table. Pion's in there, it's called a pi meson. Mesons aren't baryons, so therefore it's not a baryon, so its baryon number is 0. So let's have a check at the equation. Left hand side, total baryon number of 1, right hand side, total baryon number of 1. Give it a tick, that's conserved. Let's have a go now. Lepton number. Is the kaon a lepton? Well, we've already said it was a meson. If it's a meson, that means it's a type of hadron. It certainly means it's not a lepton, so its lepton number is 0. Is the proton a lepton? Definitely not. It's a baryon, and baryons aren't leptons, so it's got lepton number of 0. Is the neutron a lepton? Certainly isn't. It's a baryon, and baryons aren't leptons, so its lepton number is 0. What about the positive pion? Well, we've already decided that its pion is a meson, and mesons are hadrons, but they're not leptons, so that's got 0. So the total lepton number, 0 on the left, 0 on the right, so that's also been conserved. So we've shown, we haven't just written the three things down, we've shown that why it's true, it's conserved. Right, part B. The neutral kaon has a strangeness of +1. Write down the quark structure of the following particles. So it's got a strangeness, so we know that we're dealing with strange particles. In other words, we're dealing with S quarks. So we have a look at our table, and we see that an S quark's got a strangeness of -1. But the neutral kaon's got a strangeness of +1. So it can't be an S quark that's in there, it's got to be the opposite, so it's got to be an anti-S. An anti-S quark, that will give it its strangeness of +1. Now how many other quarks do we need? Well, remember it's the kaon in the table, it's a K meson, and we know that mesons consist of 1 quark and 1 antiquark. Well, we've already got the antiquark there, so we need a quark. And we need a quark that's going to give the total charge of 0. So let's have a check. In the table, The strange quark's got a charge of minus a third, so the anti-strange will be plus a third. So we've got a charge of plus a third so far. We need a total charge of 0. So what can we add to plus a third to give us a total charge of 0? It's got to be minus a third. And the quark that's got a charge of minus a third is down. So a neutral kaon consists of an anti-strange and a down. What about the positive pion? Again, it's a meson, so it's going to be a quark and an antiquark. We want to get a charge of plus 1 by combining quarks and antiquarks. So look at the table, we want plus 1, so the up quark has got a charge of plus 2/3, so we're almost there. All we've got to do is get another third. And since the down quark is minus a third, the anti-down will be plus a third. So the pi plus is going to be an up and an anti-down. And the final one we've got to do, the proton, well, you should have come across that loads of times, you've got to be able to remember it, but if you can't remember it, let's have a look at the quarks. Proton, we know it's a baryon, so we've got to get a baryon number of 1, and since all the quarks have got a baryon number of a third, we know we're going to need 3 quarks to make a proton. 3 quarks that end up giving us a charge of plus 1. So if we look at these charges, we should spot that 2 ups would give us plus 4/3, 1 down would be minus a third, 4/3 minus 1/3 is 3/3, so a charge of plus 1. So the proton is up, up, down.